think we're back. Let's see how this is doing. Well, that seems to be better. We'll keep an eye on it and see how it's doing. I also adjusted my stream and my screen layout from yesterday, so now I can actually have the YouTube chat live and the video feed and my screen all on the feed at the same time and not have the black bars on the sides, because I'm one of these weird old school people that still has 4:3 aspect ratio monitors. Streaming to widescreen format just doesn't quite work for me. So where was I? I was staring at relays. These look like fine little relays. Looks like the only major difference between these is the operate and the release time. I think I'm going to pick, actually it looks like they're also slightly different sizes. I'm going to do a side-by-side comparison on these and see if they have dimensions. Don't have dimensions there, so let's compare the datasheet side by side. This one is almost an inch long, and the width is 0.3 inches approximately. This one is 3/4 of an inch long and slightly narrower, so this will take up less board space. I think that combined with this one having better operate and release times makes this the clear choice. So, time to make yet another schematic symbol for this. Back to my schematic library. New part. Read single throw. Copy. Paste. Oh. Copied the whole component. I only want to copy the symbol. Okay. Fine. New symbol. And I really do love my hotkeys. So I've got those 4 parts, got 4 pins down for my schematic symbol. Let's see, on this schematic symbol, they've drawn the coil as an open gap. I'm going to leave it drawn as a switch symbol because I think this looks too much like a capacitor. So again, the outer 2 pins, 1 and 4, are on the switch. The inner 2 pins, 2 and 3, are on the coil. So this is pin 1. I don't need to show the display name. This is pin 2. And I'll show designator. This will be pin 3. And I can hide the name on that pin. Alright. And I need to link this into DigiKey so I can find it later. So, that was the one I wasn't using. Put my DigiKey part number into the search box. Find exactly one. Rough sanity check. Yeah, that looks like the same relay. Okie dokie. Looks good. And then I'm going to copy in DigiKey's description for this as well. Default comment. And I should check this. Oh. The part I made last night I did not link to DigiKey either, so I will go back and do that today. I believe this was the one. Yes. There's my part number. Let's see. And yes, this has the desired appropriate switching voltage on it. So that will do that. And then let me go grab the description from DigiKey as well. I should remember what the designator is for relays and update that too. Alright, Internet. DigiKey says description is K. Okay. So, update that to be K. This designator is the prefix that gets used when I drop this component onto a schematic. And then when I actually apply component labels, the question mark will get replaced with a number. So, with all of those things said, tools, somewhere I think there was an option to update all of these components from the schematic library. I don't remember what it was, though. But since I've made changes to this part in the library, you can see they're not reflected here because this is still a snapshot of when I dropped this in. I need to do that update. Comes from the library side. Update schematic sheets. No components were updated. One component updated. Alright. So, when I do that update, and now I'll see this has now picked up everything except the designator because the designator is permanent. But that's easy to fix. And now I can place a new component. I can choose my new relay. And I can place a new relay at each of these positions. I think with that, I want to move and spread these out a little bit. So I'm going to move that up. To move these up, I'm going to move this too far down. And I'll adjust the rest of these to match. Not that that really matters. And that gives me enough space to spread these out. And I'll put the designator for that one up there. And I think I want to hide symbols on these, so I can come over here to the schematic inspector, and this lets me modify multiple parts at the same time. So I can go over here to the component. I can say hide, and poof, all the names go away, which is pretty handy. Oops. This. Okay. Now it looks like we have an appropriate amount of space. these over so they're connected. Let's see. I have one viewer. Hello, one viewer. So now that I have those all set up, I'll draw the other part of the schematic here. Basically, I'm going to tie all of these together. So this will be the output from the resistor divider, as selected by whichever relay is currently active. I'll run that through. Hello, phone. Goodbye, phone. I'll run that through a protection resistor and then a clamp diode to keep the voltage to a maximum value, and then that will feed into my ADC. So with that in mind, I need to go find myself a 10K resistor. I think I'll use 10K 0603. And this can be a standard 5% part. Let's go find one on DigiKey. I might need that again. Passives, resistors, chip resistors. Like a 10K resistor. In stock and active. RoHS because it's good to be environmentally friendly. I only need one of these, and we'll just sort by price and see who comes out on top, but it's probably going to be a toss-up. Oh, those are tiny. Those are 0402s and 06, or 0402s and 0201s. Those are 40 thousandths by 20 thousandths of an inch. That is not much larger than a grain of rice. Actually, it's probably smaller than a grain of sand. I will pick some larger sizes and find some resistors that are slightly more reasonable. Yes. This looks like a more appropriate part. So, once again, it's a resistor symbol. Whoop-de-doo. Let's link it up against DigiKey. Let's find looking at the packaging type here. I like cut tape, so I'll go with that one. Say OK. Like my default comment to be 10K, and I will copy in the description of the DigiKey. There we are. And now I can place that part on my schematic. So here now I have a 10K, it's high accuracy, and one that is not. And the reason why I'm not using a high accuracy part here is that this is only conducting the leakage current into the ADC input. It's not conducting along the voltage measurement path, and therefore it doesn't need to have a high voltage or a high tolerance rating, because the exact resistance isn't going to affect the circuit performance. I think now is a good time to do what's called annotating your schematics in Circuit Studio and in Altium, and this will take all of my existing component designators, and I will say update, and it will say all of these designators that are previously unspecified now have numbers on them. I can say accept, I can say execute, and now all of my designators have numbers. Look at that. It's all automatic as I place parts. Because it is oh so much more fun, I think I'm going to take a moment and find myself some input terminals for this, because that's more fun than searching for a protection component. And I need to mute my phone because it is going nuts. Snooze. Go away for 2 hours. Alright. I think I want to do the very standard banana jack connectors that you see on basically every piece of test equipment. I think the category is banana and tip connectors. Banana jack, 418 items. Yes. I would like parts that are in stock, actively manufactured, and RoHS compliant. Usually that's not a big hit on component styles. I would also like something that is board mount, so free hanging and panel mount are not what I'm looking for. That leaves through hole and right angle. 23 parts remaining, and I can even choose my color. Let's see what kind of styles we have. I don't think that one's quite what I'm looking for. These are closer, but they're not terribly well supported. That's, I guess technically that's a through hole. I was expecting something that soldered through a hole and not bolted through a hole, but that'll do. I'm surprised that these are my only choice for panel mount banana jacks. Is there something I've done wrong? What does it look like if I remove most of the filters and look at what's here? varieties of these are tip jacks, which was the other category I chose not to explore. That's a panel mount jack. So if I choose the gender that I know I want, if I choose PCB and through hole, do I get down to a similar selection of parts? I do. Interesting. Is there another category of connectors here that I missed that might have something similar? The only thing that I think could be close would be these barrel connectors, but yeah, no. Audio, phono, power. None of those describe what I'm looking for. These are a fairly specialty parts, so I'm going to try Mouser to see if they have something. No, test and measurement is not what I'm looking for. Looking for connectors. And socket or unspecified. Oh, hello, Sam. You going to come join me and join my live stream? You going to come join me? No. Okay. I guess you're just saying hi. Maybe someday all three of my viewers will get to meet my cat. Oh. Hello, Sam. Everyone. Say hello to Samson. Samson. Say hello to the live stream. You're just here to sit on my lap and get petted, aren't you? Or maybe you just want some of my tea? No tea for you. Sam is helping me search for parts on DigiKey. Oh boy. Hey. Sam, what have you done? You pushed all of the hotkeys and done all of the things. Now you're pushing all the buttons. When it comes to sit on my lap where you will not be on the keyboard. You just want to hang out right where the action is and get attention, don't you? Okay. That looks better. Where did I put my browser window? Here we go. Oh, yep. There goes Sam. I guess I'm working one-handed now. Hi, Chris. You want to watch me design a multimeter? 90% of it is searching for parts on DigiKey. It's very exciting. Well, number of positions and number of rows gets me 1. I can at least glance through these quickly and see if any of them remotely resemble what I'm looking for. None of them really do. Well, clearly, I'm not looking for pin and socket connectors. Let's see what the unspecified connectors category has. Oh look, a screw. And whatever that is. None of these seem particularly intriguing. See, this was the connectors category. Is there a category here that I missed? Headers, I/O, junction systems? I don't think so. Oh well. Let's search for banana and see what comes out, because I want banana jack connectors. Well, I see lots of pictures of the plug side, but none of the receptacle side. Test plugs and jacks. Pomona Electronics makes some nice things. Let's see what their test plugs and jacks category has. Type. Banana jacks is a good down select on that. Big plugs. Sam is still wandering about. You gonna sit, Sam? You're almost sitting on my tea. Please do not. Okay, goodbye. Oh, the bad puns in the peanut gallery are absolutely encouraged. There's a reason why you're on screen as part of the stream. I just need to remember to pay attention. Let's see if DigiKey has a better browser for Pomona Electronics. Let's see. Connectors. That is not at all what I was looking for. Binding post bases. Don't think so. Maybe. Does this count as a circular connector? I should hope not. For reference, or for those who are not terribly familiar, I'm looking for a lead or a connector for a banana plug that looks something like this. That is the part that this fits into. They're very common on test equipment for plugging in your test leads, and they're found almost nowhere else. I was kind of under the impression that I could find a panel mount version of this somewhere, and thus far DigiKey and Mouser have both failed me. Let me try Allied. Let's see if perhaps they have something. Again, they have these, which are a panel mount. I'm really hoping for something that's more of a board mount, so that I don't have to go doing a bunch of extra work on my chassis. Go down through all of the categories. How many categories are there of these? Stock only. For miniature plugs, 0.12 inches, with a swage mount on them. is listed as a solder through hole. I'm going to have a look at the data sheet just to see what they've got. So there's a panel cutout, so it's clearly a panel mount part. Rated for 15 amps to 2000 volts. That'll do. Okay, well, it seems like this is not the panel or the PC board mount part I was looking for. Alright. I'm just going to ask Google directly. Does Newark have anything? Ooh. Here we go. Now we're talking. Banana conductor. Rated to an absurd number of amps and an absurd number of volts, which is about good. And no, Chris, my multimeter has not broken recently. I'm designing a new one because somewhere around here I have a nice collection of little Nixie tubes, and I felt like doing something with them. So I'm going to make myself a new multimeter. I will probably not be calibrating it with the other meter that I have, because my other meter is not that great. I will probably take it to work and use some of our fancy test equipment at work to calibrate it. Or rely on somebody else shipping me carefully calibrated parts so that I don't need to do a calibration. Was one of the parts of the schematic I worked on yesterday is this resistor divider network, and all of these are 0.1% accurate components, which means that I don't have to worry too much about the overall accuracy of this divider unless I really want to calibrate it tighter than that, at which point I can apply a known voltage here and measure the output and use that to calibrate away any minor offsets here and any other effects from this circuitry. I think I have finally found my banana plug jacks. This one from Cliff Electronic Components, and this one from Staubli both look like nice stout parts. I've seen and worked with some components from Staubli before and generally been impressed. Let's have a look at their datasheet. So, oh, that's a different version. They've got a couple on here, it looks like. So here we are. They give a board mount pattern. Oh, it's in German and English, and okay, that's German. That's English. I don't recognize that language. They're a European manufacturer, so I'm not too surprised. So this is showing the bottom And that's it. And let's see what the data sheet on this. Wow, that looks nearly identical to the Stably part at half the price. You can get it in colors. I like colors. This shows a panel layout. That's very nice, and they've got a dimension here for the dimension to the edge of the PCB. Very handy. This seems like exactly the kind of part I'm looking for. I am so deeply in love with DigiKey that I'm going to see if I can find them on DigiKey. Chances are slim to none. Let's see if I can find the manufacturer. I suspect not. Aerostat, CMD, they'd be in here somewhere, and they're not there, so it looks like I have to buy one or two of these from Newark. Fine by me. And do they have a 3D product? Oh gosh. Yeah, I should have expected that. That's the part number. I'm just gonna save this to my downloads folder, and this looks like it's a step file. Thanks, Windows. No, I didn't want you to add another file extension on this. It really is what I told you it was. It's a step file. Change file name. It's okay. Unlike some certain pieces of software, finding documentation in multiple languages is usually a good sign. It means that more than one person is using this. Would I like a template for that? I have looked at several. Let's see if I can find. Well, that's a shame. They're only stocking the blue one and the red one, the black one. Wait. I was just here. I did a search for that part number. It didn't show up. And yet, if I do a search for the red part number, I can find it. Note to self, Newark is just slightly insane. Okay, I think I want black for my common, red, and I will choose yellow for the third terminal. We'll see if they stock the yellow one. They stock the yellow one. All right. Once again, back to creating another model for this component. I think I'm going to call this where did that go? supplier link here for somebody other than I can enable Newark. Description. Okay, maybe I should enable those. I'll enable the Newark part search and search. So can I link all three of those? I can. Look at that. So that is black, red, and yellow. What is it, Sam? What are you looking for? Oh, Sam. Chris loves you. See you around, Chris. Let's see if this part has a schematic symbol. Nope. Okay, I think common schematic symbol for these is a Y sort of thing. Drop a single pin. With a Y on it, and that will be my component. And this is socket, PCB, all of these things. This will be a banana jack. Let's see if there's an option to adjust my Okay, I guess I can't adjust too much what comes in. Kind of unfortunate because the full-featured version of Altium, when you do a supplier import, it will pull in all of the different parameters. So the manufacturer's part number, the manufacturer name. It'll usually pull in the description from DigiKey, all those things, but less full-featured software has fewer features. Well, let's put a few banana jacks on this board. So there's 3 banana jacks. This one. I will relabel these as with their functions. So voltage, common, and current. And the current option will come later. So that's linked through. Actually, while I'm here, while I have, like that was the nice stone. While I have the datasheet for this open, I'm going to do the PCB footprint for it as well before I lose that completely. I'm going to add a new PCB library. And then I need to reproduce this on my PCB library. So I think the 4 surrounding pins are just for support. I don't think they're electrically connected. It would be nice to have one of these in hand to check out, but such is not the way of things. What units am I dealing with here? Well, that says 4 millimeters on it. This does not indicate size. That is rather unfortunate. Does not indicate units. Who doesn't put units on their data sheets? I guess these people don't. I think the only reasonable assumption is that this is metric, particularly given that the only other units on here are metric. And this is a UK company, so let's go with that. Since that's wide, I'm going to try to stash it at the bottom of the screen. I guess Circuit Studio had a bad moment there. You fit. There's my center. What are my grid options? Okay. Step 1. Come now. Units, please. Going to go with a 0.5 millimeter grid. So let's see, I want to place lines. I'll just do an outline. Top overlay is their layer for the top silkscreen layer. This is and the width is 12, so 1, 2. Library options, units, metric, yes. Now my units that are showing up down here make some goddamn sense for this part. So this one is, according to this, no windows, that wasn't what I wanted. It's 13.5 millimeters. I'm going to put my origin around this pin because that seems like a reasonable thing to do. This is 13.5 millimeters, which means this needs to be 13.5. Move. There's 13.5. On the other side, (19 minus 13.5) is 5.5. So adjust that until the X says 5.5 millimeters. And then I think all of these lines 0.25 millimeters. Lucky me, I have my handy dandy DigiKey ruler, and among other things, this has line heights and sizes on it, all possible line thicknesses and sizes. The most appropriate part of this ruler today is this section showing line widths. According to that, I think my appropriate line width is 0.25 millimeters. So I will increase this by a factor of 10. And oh, that looks much better. Okay. Here we go. Me always saving things. I'm going to place pad. I can hit tab, so this is going to be center pad. You can see down here it should have a diameter of 2.2. So 2.2 in the X, 2.2 in the Y. Hole size also of 2.2. Okay, so this needs to be larger. The pin number for this was 1. That's good. This should be a plated hole. It's round, it's drilled. There is a recommended annular ring size. So the ring here, between the edge of the hole and where the edge of the copper is called the annular ring. Here we are. Somebody is quoting the one of the standards, and this says nominal is 0.35 to 0.3. So I'm going to do 2.2 plus 0.3 plus 0.3, which is 2.8. And just by eyeball, that looks about right. Now let's actually put that in the middle of my part. And then I want another pad for the other hole. This one is going to be 2 is fine for this. For its ID number, these are a 1.2, so I'll do a 1.2 millimeter hole and a 1.8 millimeter pad on that hole. And these are in kind of a square pattern. It's not quite perfect, so I'll put a bunch of them down and come back and clean them up later. I'm going to rename all of those. Then I can take these two and I can adjust their x-coordinate to be 3.8 as mentioned here. Now I need a calculator. (10.16) minus 3.8 is 6.36. So the x-coordinate for these is minus 6.36. And again, I need a calculator, so these are plus and minus off my 0 of half of 10.16. So that is 5.08. So these two will be 5.08, and the other two on the other side will be minus 5.08. So now I have these 4 pads on a center hole that match my data sheet. I have an outline here, which is the same rough size as the overall size of the part. This serves mostly as a guide for when I'm putting these parts on my PCB. I have an idea that, yes, okay, that's about the right size for them. And when I'm doing layout, it'll give me a chance to make sure it's about the right size. And then the other thing I will use during layout is this edge here. Since this is the edge of the flat part, I'll align this up with the edge of my PCB so that then the rest of the jack can stick through a hole in the chassis. The final part on this that I like to do, and that not all software will do, but that is very handy, is I like to put in my 3D model. 3D model. Okay, where is... Where is my PCB Library Explorer? Alright. Of course, some of these features are only available if you go and search for them. This is my 3D model. Say OK. Let's put this in here. I'm just kind of going to guess that it goes something like that. The real test is to put it in, see what it looks like, flip back over to 2D mode, spin it around, I will look at it again in 3D mode. Probably be a standoff height here. I'm going to guess 6 millimeters. Not bad, but we can see here that this part that's supposed to be standing on the PCB is instead sitting on the leg there. So try 6.5. Has moved up just a shade too far. So I'm going to try 6.3. And that is more than good enough for a visualization of this part. The other thing I can check while I'm in here is I can look at it from a bottom view. I can see that yes, in fact, all of the pins on the manufacturer's 3D model, if I look at them straight down, line up and fit within the holes that I've chosen. On a 3D model like this, you want to see just a little bit of space right in between there, because that will be filled up with solder when you actually do your assembly. So that gives it a little bit of fit, and if any of these things are inside the wrong place, you'll still be able to put it together. The other thing I see here I really like is that I can see my board outline, and that is perfectly around the bottom of this component, right where I wanted it to be. So that's great. So with that, I can come back over here. I think I need to modify my schematic symbol. So initially I'd done this with a pin, but I think I need to draw this I'm going to draw this with a shield around it and then connect that. Connect this shield to the 4 outer pins on this connector. So there's pin 2. I will adjust that manually so that it lands. Not totally convinced I like that. That needs to be the other way if I want to hook anything up to it. This end with the slight dots on it is the end where I actually have things connected. I don't like that schematic symbol. Other people draw banana jacks. Ah. They draw them as concentric circles. I like that. I like that much better. Okay, that part goes away. I'm just going to redraw the whole thing. Circle. Second circle. Do a line indicating that this pin connects to the inside and this pin is some outer part of this. This one, I'm going to adjust the arc radius. This one, same thing. Here I want to make sure that this line, rather than ending at 0, ends at an x of -5. And I think I want both of these to be black. There we go. And then if I right click on this, now I can add a footprint for this. Associate this with did this end up?
Sam.
Hello, Sam. Okay.
Sam.
Free documents. This is supposed to be
No. No.
okay. I had saved that not in my project. That's why it was so confused. So now, if I go to add a model, and it's a footprint, and I browse, here we go. Oh. Really? I named that PCB component 1. Let's fix that before we try to associate it with anything. This was a FCR 7350. This is a banana jack. once more. That looks good. Save. Updated 3 components, 1 schematic. That's what I expected to see. Over here to my schematic, and now I see that, yes indeed, this banana jack has been updated. Oh, I don't actually want to align this. I want to rotate it. Mirror. Rotation. Done. And then I can place grounds on all of these so they're tied to my chassis. Normally that's more for noise immunity than anything else. Okay, with that in place, the next thing I need is to go find a diode. So discrete semiconductors. Really what I'm looking for here is it's called a transient voltage suppressor, or a TVS. Well, DigiKey has a category for this called circuit protection. That's why they didn't show up in diodes. Some of these are diodes, some of them are metal oxide varistor. In either case, it's a component that has a very low leakage current until it turns on. It usually turns on at some high voltage, and then once it's at that voltage, it will conduct rather substantially to bring the overall system voltage down and prevent that voltage from showing up on the input to whatever other device you happen to have connected. In this case, I'm looking for a TVS diode for my input. I talked about it here. Nope, not really. Some of these are bidirectional. That's interesting. I have not seen that before. Have a max clamping voltage of between 5 and many volts. Looks like I filtered that a little too tightly. I care most about that clamping voltage, so let's see what we have here. Read the data sheet for a low capacitance ESD protection diode. This has a very small capacitance. Is a working voltage of 5 volts. It is 2 diodes back to back. Okay, so one of these will be in breakdown when the other one is in conduction. Has a rated pulse current, pulse waveforms. This nanoamp leakage number, particularly at 50 nanoamps. Well, that doesn't sound like much. If I'm in one of these lower ranges, and I have 10 megs of input resistance, that 10 to the 6th input resistance, if I do calculations over here, times, what's my leakage? I times R is half a volt. So this 50 nanoamps of leakage current, when dropped across a 10 meg resistor, will change my input reading by a whole half volt, which is sort of insanely low, but also completely unacceptable for a meter of this variety. So I think I need to find a different variety of protection diode to go here. I think this is probably a good point to go back and look at one of the reference designs and see what they chose to do for an input protection. So this is a TI reference design that I was using as one of my references. What's up, Sam? You tired of listening to me talk? Hello. You just like staring out the window? Oh. Hi, Sam. You just want some attention, huh? You just want some attention. Hello. I think he wants to play. Okay. I'm gonna stop the stream for a bit, play with the cat. Probably come back to this tomorrow.